If you scrub every dish before loading, you are probably wasting water and time for nothing. 155-degree water and enzyme chemistry clean your dishes with zero scrubbing. Here's how. Here's the thing almost nobody checks. Most people pre-rinse and hand scrub for no reason, burning water, time, and effort the machine was built to save. The machine barely scrubs at all. It dissolves. Understand the mechanism, and you load it right and get cleaner dishes with less work. Start with the muscle. There is no sponge inside a dishwasher. The mechanical work comes from spray arms. A pump pushes water at high pressure through small holes in rotating arms below and above the racks. Watch how the arms spin. Nothing turns them by motor. The water blasting out one side shoves the arm the other way, like a lawn sprinkler driving itself. That spinning sweeps jets across every angle of the load. The bottom arm hits from beneath, the top arm rains down, and the pressure is what does what your hand used to do. A sponge works by friction. You drag grit across a surface until it lets go. The jets replace that friction with force and reach, striking food from directions a hand can't. But raw water pressure alone won't touch baked-on grease. Cold water just slides off fat. So the next question is heat. Why does the same water clean far better once it's hot? Now the heat. An electric heating element in the base warms the water to roughly 120 to 155 degrees, about 49 to 68 Celsius. That temperature matters more than it sounds. Fat and grease are basically solid at room temperature and slippery when cold, but heat softens and dissolves them, so hot water carries grease away that cold water leaves stuck. Heat does a second job too. Every chemical reaction in the tub runs faster when it's warm. The cleaning agents work quicker in hot water than in cold. And at the end, that same heat helps sanitize and dry. A sanitized cycle pushes past 150 degrees, hot enough to kill most bacteria, and hot dishes flash off their own moisture as steam. So heat dissolves the grease and speeds the chemistry. But water and heat still aren't digesting the dried egg welded to your fork. Something has to actually take those food molecules apart. What's doing the eating? Meet the eaters. Modern detergent is packed with enzymes, tiny biological tools that chop specific food molecules apart. To do the heavy lifting, proteases go after proteins, the stuff in egg, milk, and meat. Amylases go after starches, the stuff in potato, rice, and sauce. An enzyme is a catalyst. It snips a big, sticky food molecule into small pieces that dissolve straight into the water. No friction needed, no scrubbing, just chemistry taking the mess apart. Here's the part that surprises people. This is exactly why the instructions say don't pre-rinse. Enzymes need food to grab onto. Scrub the plate spotless first and you starve them. You've thrown out their work before they start. There's a catch though. Enzymes are fussy about temperature. They speed up as it warms, but too hot and they cook and fall apart, losing their shape and their grip. That's the real reason the wash sits at a moderate temperature instead of boiling. So enzymes dismantle the food. But broken up soil still has to be lifted off and washed away. What finishes the job? Now the chemistry crew that cleans up. Two more ingredients finish what heat and enzymes started. First, builders, things like sodium carbonate and citrates. They do two jobs. They soften the water by locking up the minerals in it, which otherwise clog the detergent and make it useless. And they raise the pH, making the water more alkaline. High pH turns leftover fat into a kind of soap on the spot. The grease essentially cleans itself off. Second, surfactants. A surfactant grabs a loosened bit of soil on one end and holds onto water on the other, so it lifts the gunk off the dish and keeps it floating instead of settling back down. That last part is the quiet hero. Without it, all the food the jets and enzymes knocked loose would just redeposit on your clean glasses as a film. Together, softened water, high pH, and surfactants lift every loosened scrap and hold it in the water. So all four systems have done their part in one wash. But a dishwasher doesn't do it in one pass. It runs a sequence. Why the stages? Here's the whole run in order. It starts with a pre-wash. A burst of plain water knocks off the loose stuff and wets everything down. Then the main wash. Detergent goes in, the water hits full temperature, and jets, heat, enzymes, and builders all work together on the real grime. Then it drains that dirty water away. Now a key detail most people miss. The water doesn't just recirculate filthy. A filter, and on many machines a small food grinder, traps the loosened debris so it isn't sprayed back onto your dishes. Then comes the rinse. Clean water to flush off every trace of detergent and suspended soil. And finally the dry, where a helper called Rinse Aid earns its keep. Rinse Aid lowers the water's surface tension, so instead of beating into droplets that dry into spots, the water sheets off in a thin film and slides away clean. Each stage sets up the next. Pre-wash softens, main wash cleans, drain and filter carry the mess out, rinse clears the field, dry finishes spotless. 5 stages, 0 scrubbing. But if it's this good, why do dishes ever come out dirty? So why do yours sometimes come out gritty? Every failure traces back to one of these 4 systems breaking down. It's mechanism, not magic. Start with the jets. If food or hard water scale plugs the little holes in the spray arms, the pressure drops and whole sections of the load never get hit. Overcrowd the racks or nest bowls together and dishes shadow each other. The water can't reach what it can't see. Next, the chemistry. Pre-rinse too thoroughly and you starve the enzymes exactly as we saw. No food, nothing to break down. Use old or wrong detergent, or let cold water feed the machine and the reactions never get going. Then there's your water itself. Hard water leaves a chalky film, and a clogged filter recirculates the very debris it's supposed to trap, redepositing grit right back on your glasses. Notice the pattern. Every complaint maps onto a jet, a temperature, an enzyme, or a mineral problem, a system that got blocked or starved. Fix the system and the symptom disappears, which points straight at how to run it right. So here's the machine fully open. 4 systems, no sponge. The jets deliver force and reach where your hand used to go. The heat dissolves the grease and drives the chemistry faster. The enzymes digest the food into pieces that dissolve on their own. And the builders and surfactants lift the loosened soil and hold it in the water so the rinse carries it away. Put that to work in 4 moves. Scrape your plates, don't rinse them clean. Leave the enzymes something to eat. Load facing the arms so the jets can reach every surface. Use fresh detergent and rinse aid, not a box that's been open 2 years. And run it hot. Do that in 155-degree water and enzyme chemistry really do the whole job. The zero scrubbing promise now fully explained. So a dishwasher doesn't scrub. Jets deliver, heat dissolves, enzymes digest, and chemistry lifts it all away. 4 systems, 0 effort from you. Next time you run it, listen to that mid-cycle whoosh. That's the pump. And the next box worth opening. How does your microwave heat food from the inside out?